you don't have to memorize anything, basically. Once you know this, you divide by sine squared and you see what you get. But this is not the one we need. So if we divide both sides by cosine squared, this is exactly what we need. So we will be replacing 5 plus tangent squared by 4 plus 1 plus tangent squared. But 1 plus tangent squared is secant squared. So we have 4 plus secant squared. So then from here, we continue. Very interesting problem. Thank you for bringing that. We have the integral from 4 plus secant squared theta d theta. And from this moment on, it's a piece of cake. Because we have 4 theta plus. Which function prime is secant squared?
Tangent?
Yes. So that's it. There is nothing else we need to do here. We did not use a substitution, so we don't have to go back to anything. This is the final answer. And
Thank you.
thank you. In Calc 2, we would be able to do other things with it, but this is the most straightforward. No substitution is needed. Good. Excellent. Other questions? And we also refreshed our memory on a very important trig identity from which we pull out 2 other related trig identities. Good. Very good question. Thank you. Anything else? Other questions?
Can we go back to the list of topics?
Yes, yes, of course.
With the Riemann sum stuff, I guess, can we look at some problems that
Yes.
will emulate what we're looking
Yes,
at for the
yes,
test?
of course. So let's come up with a function and an interval. What type of function can we work with in the limit of the Riemann sum?
Continuous?
Cor
Well,
correct, correct. But what type of function?
Oh,
Polynomial?
Polynomial, degree 1, 2, or 3. Awesome.
yes.
Perfect. So let's choose a function. Let's choose an interval. And then we will definitely check with a definite integral.
I'm looking one up.
Any function, you can make one up. As long as you don't say tangent squared.
Okay, I see one. X squared minus x, and we'll add a, that's fine. And then it's over 0 to 2.
That's it?
Yeah.
Perfect. Remember the 3 preps. I do not put anything together before the 3 preps. First prep is delta x. 2 minus 0 over n. And thank you, by the way, for choosing 0 as the starting point. Then xi, which is I delta x. I delta x. It should be 0 plus I delta x, but it's 0. So 2I over n. For the function now, I have to find f of xi, which is f of 2I over n. No biggie. 2I over n squared minus 2I over n. Squared, 4I squared over n squared minus 2I over n. The preps are done. Now I can write the area equals the limit as n approaches infinity. From delta x outside, the sum from I equals 1 through n from this. Let me put brackets here. It's the same thing. We can use nested parentheses, but it looks better with brackets. It doesn't matter. but it looks less confusing, I think. Okay, so now a property of the summation notation is sum of the first generic term, in this case minus the sum of the second generic term. But I already realized, and I'm thinking ahead, that this is a constant. And this is a constant as a factor. So it will go outside. Because this is so much writing. So I'm going to try and reduce that if I can a little bit. So 4 over n squared, the sum of I squared, minus 2 over n, the sum of I. At this point, I will get rid of the summation notation. This is the ugly one, because it's n, 2n plus 1. I meant to write n plus 1, 2n plus 1 divided by 6, same thing. This one is n plus 1 divided by 2. But I would like to multiply these already. It's always better, because otherwise we have to write and write and write. So this is 2n squared plus 3n plus 1. I'm going to write it one more time because it's not very clear there. Okay, page 5. So this equals limit as n approaches infinity, 2 over n. So I have 4 over n squared times n, this product, 2n squared plus 3n plus 1 divided by 6, minus 2 over n times this, n plus 1 divided by 2. Okay, careful with simplifications, because I realize that I will simplify one n, of course, but I realize that the denominator will have to be 6n. So even if I simplify, I shouldn't, because it's not going to make any difference. I still have 6n. So the denominator here is 2n, but the least common denominator is 6n, so this needs to be multiplied by 3. So then limit n approaches infinity, 2 over n. So 4 has to be distributed. The least common denominator is 6n all over. 4, so 6n is fixed. 4 times 2, 8n squared. 4 times 3n, 12n, and plus 4. Careful now, because the denominator again was 2n. I need 6n, so that's why I need to distribute 6n to these two with minus. Minus 6n squared minus 6n. 6 times n with minus in front. 6 times n times 1 with minus in front. Finally, we have, I shouldn't say finally just yet, the least common denominator is 6n times n, which is 6n squared. Here we have 8n squared with minus 6, so it's 2n squared times 2, 4n squared. And then we have 12 minus 6, which is 6 times 2, 12n. And we have 2 times 4, which is 8. I already know the answer is 4/6. Okay, let's say we don't know. It's infinity over infinity. Limit as n approaches infinity. 8n plus 12 over 12n, of course, over 12n. Again, infinity over... One more time. 8n plus 12, 0, 12n. Correct. Infinity over infinity. So limit as n approaches infinity. Again, 8 divided by 12, which simplified by 4 gives us 2/3. 4 over 6, 2/3. So this is the area. Who cares? I need to find it, to check. Make sure that 0 to 2, x squared minus x dx. And this is the moment of truth. I have to get 2/3. So x to the third over 3 minus x squared over 2 from 0 to 2. Thank you again for gracefully choosing 0 as the lower limit. So I have 8/3 minus 4 over 2, which is 2. 3 times 2 is 6. 8 minus 6, 2/3 indeed. This took barely a line, and the other one 2 pages. Very good pick, thank you.
Is this what we should expect as far as like a Riemann sum question?
Yes, yes, exactly. Again, it's okay to use L'Hopital's rule, but here you can, it's the same degree of a same degree, and when n approaches infinity, so you can write the answer 4, 6, and then simplify it to 2/3. I'm fine with that too. By now we know that. Good, perfect questions. Anything else you would like to pick or other questions you need help with?
What is the integral approximation?
Right.
What is that referring to?
Very good. So let's take a look at that. So I think I'm on page 6. Yes, 6. Good. So, for example, if you want to determine the integral from natural log of x to the 4th dx from 1 to 4, we will not be able to find the antiderivative. We're not able to determine antiderivatives for all functions. For this one, we cannot. If you ask me what is the antiderivative of this function, I'll say I have no clue. I could put the 4 in front. I have to use integration by parts, and I will be able to determine it. But at this point in time, in this course, the problem will ask us to approximate it using n equals 3 subintervals and midpoint. So this particular one that I just chose, it's doable, but I have to show a method called integration by parts. But we are only asked to find an approximation using 3 subintervals and using the midpoint. So my starting point is, and I have a video that I showed and I posted for you in this module with the videos and lecture notes, how to go about this step by step with a calculator. So 2 and 3, and the midpoint will be 1.5, the midpoint will be 2.5, and the midpoint will be 3.5. So this will be approximately delta x, luckily is 1, f of 1.5 plus f of 2.5 plus f of 3.5, and we have to approximate that. So I would plug in stats, I edit, and I edit list L1, entering 1.5, 2.5, and 3.5. And then move to the highlight the title of column 2, and I will have in there simply natural log of list L1 raised to power 4. No, not there. Here. And when I click enter, I will get all these numbers, and then I go to second and exit, stats. I want to calculate one variable stats with list L2, and I will copy exactly what I need, and here's the sum. So the answer is 10.29807523. The calculator should give us, in this case, for the example I just picked, should give us an exact number, which should be quite close. So we have natural log of x to the fourth. Don't forget parentheses. You're not going to get, probably not the, I don't know. So when I click enter, I should get 10.1807. So this is the exact, with our approximation was 10.298. So these situations, we have other methods, of course, but we are not discussing them in Calc 1. Of course, the approximation would have been much better if I had chosen 9 subintervals, for example, and so on and so forth. But I'm not trying to torture you. 3 subintervals is good enough. All I wanted what I wanted to see is the method. And that's all you need to show. And not copy, we just wanted to verify our approximation, not copy a value from the graphing calculator. You have to show these steps, and whatever it says for the decimal digits, then you will have 2981 if it's 5 or 6, whatever. Any questions on integral approximation?
No, I'm good, thank you.
Perfect. Okay. Anything else you would like to go over? Or do you have other problems for me that you worked on or you need help with, or you simply want to see again? All of the above.
I know you said we were going to spend tomorrow on the rest of the chapters for the review, but
yes.
I think that's
but not this, unless you have questions, of course. I will always answer your questions, but this should be done. So we should go back in time in chapters 2 through 4. But whatever you want, whatever you need. So what is the next question?
Can we do from 5.2 on the web assign?
Yes.
Question 5.
Yes.
The question is, if you're ready.
I'm ready.
It's express the limit as a definite interval or on the given interval, excuse me. And it's limit as n approaches infinity of sigma n I equals 1 x I ln
from I equals 1
I,
to n, yes?
Yes. xi subscript I.
Yes.
Natural log 1 plus xi squared xi subscript I, excuse me, delta x on the interval 0 to 3. And then the input is in the summation symbol, so it's summation, I mean not summation, integration symbol 0 to 3 dx.
Of course, yes. We're going to get, let me just read this back to you to make sure that this is okay. The limit as n approaches infinity from the summation from I equals 1 through n. And now we have a product. xi times natural log of 1 plus xi squared, close the parenthesis, multiplied by delta x.
Yes, and all the xi's are x subscript I.
Yes,
Just
yes,
so
yes,
yeah.
yes. So
then it's good.
yes, so just to make sure, this is what we had here. This is the xi and this is the xi. It's not x times I, as you just said, perfect, is xi. So this is
x little I.
okay, perfect. So, no, I know. I just wanted to emphasize what I just yeah, perfect. Okay.
Sounds good.
Okay, so we know that this must be a definite integral. Yes, of course, is the definite integral from 0 to 3 from something dx. And obviously this must be the function. So let's identify the function.